Time for 7 minutes with 7SIGNAL, where we take a little feature inside 7SIGNAL, unpack it in order to show you how a little thing can have a big impact. So today we were talking a little bit in our presentation about voice, and so I want to talk a little bit about voice over Wi-Fi with you guys today. Voice over Wi-Fi, as you know, is just so critically important in today's environment. I mean, I'm doing it right now. And it's important to note that 7SIGNAL, when we do our active tests, we're actually doing voice testing over the internet, over and out to our sonar endpoint that we have out there. We're passing UDP packets. And as you know, UDP packets, we use those in voice because it's sort of like a connectionless protocol that allows us to just speak, and it doesn't have all of that error correction in there and such that TCP does. And the reason why we need that is because, otherwise, when I'm talking to you right now, if it kind of waited to handle all of or do all of that error correction, you might not even be able to hear me at all. So it's very sensitive to interference. And what I want to do is I want to show you in 7SIGNAL how we test for it and how we can associate it with root cause. Here we go, guys. Okay, and we're gonna share screen number 2, and there we have it. You should be able to see that. Give me the old nod. All right, so here we go, guys. This is the device, somebody's laptop computer, and as you can see, I'm on the voice tab over here, and every few minutes, we're passing those UDP packets back and forth between the person's device and our sonar endpoint that's out there in the cloud, this Central One sonar out there in the cloud. And this is simulating voice traffic. This is simulating me talking to you guys right now in many respects. As you can see here, that the voice quality really took a nosedive at this time. We calculated a MOS score of 1.8, and the MOS score, which stands for mean opinion score, a metric that we use in order to characterize the quality of the voice conversation over Wi-Fi, is made up of these 2 factors or indicators that we're also calculating: packet loss and jitter. Okay, so remember, UDP, kind of like that unreliable connectionless protocol, it doesn't have all of these mechanisms in it for kind of repairing the transmission. And so packet loss needs to be measured, because if there's too much packet loss, it's going to be a horrible voice connection. Same thing with jitter. With jitter, think about that as the latency that occurs, the delays that occur in the whole transmitting and receiving process. And so if we have too much jitter, again, it's going to be a horrible voice experience. Now, as you can see right here, there was a huge spike in jitter, 16 milliseconds. And quite frankly, when you have jitter that kind of gets into the teens like that, that's going to cause a problem with your voice quality. It really should be in the single digits, okay? 4 or 5 milliseconds of jitter, probably no problem at all. But you start to get into over 10 milliseconds of jitter, and you're going to start to have that problem. And so once again, you can see. Now, let's correlate this, what we've detected here in terms of a poor experience, to what else is going on around this person's device. Now, if I look over here, what do I see? I see that the person was on channel 6, 2.4, where we all know there's more interference. Not only that, but if I inspect it even a little bit more, they were tethering to their iPhone, which, is not going to be the most reliable connection. Obviously, it's setting up shop on channel 6, 2.4. Now, when does the voice quality improve? As you can see, as I continue to mouse over, it improves when they find themselves back onto their corporate network, and they're on channel 44 on 5 gigahertz. You can see as I move my mouse over here in the lower right corner that the connection quality improves up here as well. Isn't that remarkable? So again, when people call and they say that they have problems, we want to be able to confirm there's a problem, and we can do that. Yep, indeed, poor voice quality. And then we want to correlate that to what's going on in the environment around this person's device. And in this case, it's interference, as you can see very clearly where my mouse is right here. This interference being on channel being on channel 6, tethered to the iPhone on 2.4, is definitely going to cause these problems. If you're going to be doing voice, you want to be on 5 gigahertz, where hopefully there's a lot less noise and a lot less interference. So there you have it, guys. 7 minutes with 7SIGNAL. And remember, you and me, we can't hear, we can't see Wi-Fi, but 7SIGNAL can. Thanks for joining us today.